Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. Okay, Lesson 10, Basic Trigonometric Identities from Graphs. Classwork Exploratory Challenge says, consider the function f of x equals sine of x, where x is measured in radians. So before I go any further, this will no longer be said. They're just getting you familiar. How do you know if they don't say where x is measured in radians? There is no degree symbol inside here. If there's no degree symbol here, you assume radians. All right, so bring in the unit circle. Hopefully you know these values already, but I brought them in just in case. All right, so these are the important values, pi over 6, pi over 4, and so on. This is the unit circle in radians and what the cosine and sine value are at that radian measure. So graph f of x equals sine of x on the interval from negative pi to 5 pi. So since these are 1, 2, 3, 4 units for every pi, they're going in quarters. So I'm going to label every single one of these first. So let me bring this up. So this location right here, I'm not going to put those hash marks. Just take too long and get messy. This is negative 3 pi over 4. And this is negative pi over 2, negative pi over 4. This is pi over 4. This is pi over 2. And this is pi over 4, but it's 3 of them. Let me fix that. 3 pi over 4. And we're going to continue throughout, but that's enough for now just to get us started. So now it says to graph these values. So let's start with negative pi. And the value of sine at negative pi is going this direction around till we get to here, and the sine is the y value, or 0. So then I plot the point at 0. Okay, and we're just going to keep doing this. So the next thing I'm going to do is negative 3 pi over 4. And I'm just going to write these out first. Negative pi over 2, negative pi over 4, 0, pi over 4, pi over 2, 3 pi over 4, pi. Pi plus a pi over 4 is 5 pi over 4. 6 pi over 4 is 3 pi over 2. 7 pi over 4. 8 pi over 4 is 2 pi. Okay, and these are just going to keep repeating now. So rather than spend time on this table, let's just fill in the values and then we'll just keep repeating. Because once we go around the circle once, we do the same values over again. So negative pi, sine was 0. Sine of negative pi is 0. Sine of negative 3 pi over 4, well, 3/4 pi over 4, negative 3/4 pi. Here's pi over 2. 3/4 pi is right here. Negative 3/4 pi is equivalent to 7 pi over 4 going the positive direction. And the y value here is negative root 2 over 2. The sine of negative pi over 2 is equal to 3 pi over 2, and it's negative 1. And then the negative pi over 4 is the blue one here. That's equivalent to 7 pi over 4, and it's negative root 2 over 2. Sine of 0 is 0. Sine of pi over 4 is this positive root 2 over 2. Sine of pi over 2 is 1. Sine of 3 pi over 4 is right here, root 2 over 2. Sine of pi is 0. So rather than keeping on going there, since we started at negative pi and we did a full rotation getting back to pi. So these are just going to keep repeating. So let's plot those points now. Okay, so negative pi, 0. Negative 3 pi over 4, negative root 2 over 2, which is, and if I go into my calculator, negative root 2 over 2 equals negative 0.707. So negative 0.5 is here. We're down a little bit more. It would be right here. Negative 3 pi over 4 was root 2 over 2. Negative pi over 2 is negative 1. Negative pi over 4 is negative root 2 over 2, which is about right here. And then we get back to 0 and sine is 0. So let me just draw this as neat as possible. This comes down, turns, goes back up. All right. And then we continue to pi over 4, which is right here. And that's going to be the positive root 2 over 2, which is about here, 0.7. Pi over 2 is 1. 3 pi over 4 is going to come back down to root 2 over 2. And then pi is equal to 0. So now this is going to come up, turn, come back down. So there is the sine function from negative pi to pi. Now this is going to repeat. So as I go, this is going to be negative root 2 over 2. This is going to be 0. This is going to be root 2 over 2 and back to 0. Positive root 2 over 2, 1, root 2 over 2, 0, negative root 2 over 2, negative 1, negative root 2 over 2, 0, root 2 over 2, 0, or 1, root 2 over 2, 0. So now just let me draw this and let me pause the video so I don't bore you. Okay, so part A now says using one of your colored pencils, so I switched to blue, mark the point on the graph at each of the following pairs of x values. X equals negative pi over 2 was negative 1. And I'll mark that right here, negative 1. And x equals negative pi over 2 plus 2 pi. Well, that'd be going from here, adding pi. How far is pi? 4 squares. 1, 2, 3, 4. That's pi over 2. That's 1 pi. 1, 2, 3, 4 would be 2 pi. And that puts me right here at negative 1 again. So then if I pick the point pi, that is 0. Add 2 pi to pi, you're at 3 pi. That is also 0. Seven pi over 4. Well, this is 3 pi over 4, 4 pi over 4, 5, 6, 7 pi over 4. We're at negative root 2 over 2, which is right here. And then add 2 pi to that, and we'll end up at, so that'd be 8 pi over 4 plus 7 pi over 4 is 15 pi over 4, 8 pi over 4. This would be 12 pi over 4, 13, 14, 15 pi over 4 gets us to this point right there. And that is also negative square root 2 over 2. So what can be said about the y values of each pair of x values marked on the graph? Okay, so for each pair of x values, the y values were the same. All right, page 2, part C says, will this relationship hold for any two x values that differ by 2 pi? Explain how you know. Well, let's go back to that graph. And I'm going to draw a line segment that is of length, you guessed it, 2 pi. So if I start at 2 pi right here and bring it back to the origin, That is a distance of 2 pi. And then if I take this and put it at the top here, okay, actually it's a little bit too long. That's a little bit more than 2 pi right there. So there it is, and bring it over to 0 to 2 pi. As I'm following this graph with the left edge, the right edge is on the graph 2 pi away. So there is the picture of what's happening. Okay, the values are always going to be a difference of 2 pi. Or what I should say is, for the values of every 2 pi added to any value, your y value is going to be equal. Okay, so yes, since the sine function repeats every 2 pi units, then the relationship described in part B will hold for any 2 values that differ by 2 pi. All right, so part D now says, based on the results, make a conjecture by filling in the blank below. So for any real number x, the sine of x plus 2 pi equals, well, if we're on the sine function and we add 2 pi to it, we end up on the sine function again. So the answer is the sine of, the sine of x. Okay, E. Test your conjecture by selecting another x value from the graph and demonstrate that the equations from part D hold for the value x. So I'm just going to do that right here. Okay, so you can pick any value you want, but I picked sine of pi over 2 for this answer. So if I look at the sine of pi, 5 pi over 2, that equals the sine of pi over 2 plus 2 pi. Because 2 pi is 4 pi over 2, and 4 pi plus 1 pi is 5 pi. And that will equal the sine of pi over 2, which is 1. So let's go take a look at my graph. What we want to see is the sine of pi over 2 is 1, and the sine of 5 pi over 2 should be 1. So if I go here, the sine of pi over 2 is right here, and the sine of pi, which is 2 pi over 2, 3 pi over 2, 4 pi over 2, 5 pi over 2 is right here. So then if I take my segment that I drew that's 2 pi long, then as you can see, the values are equal. They're both 1. So that's what this says here. F, how does the conjecture in part D support the claim that the sine function is a periodic function? Okay, so the sine function repeats every 2 pi units because 2 pi radians is 1 full term. Thus, if we rotate the initial ray through x plus 2 pi radians, the terminal ray is in the same position as if we had rotated by x radians. Now G says to use the identity to evaluate the sine of 13 pi over 6. Now I keep going back to the graph and keep going back to the unit circle, but if you just think about this, what is 1 full rotation? 1 full rotation is 2 pi. All right, so 2 pi is a full rotation. If I have denominators, then how many of those denominators do I have to make 2 pi? Well, the denominator has to be half of the numerator to get a 2. And what I mean is, if I have pi, 2 pi is equal to 4 pi over 2, right? That is equal to 6 pi over 3, and that is equal to 8 pi over 4, which equals 10 pi over 5, which equals 12 pi over 6. Now notice I have 13 pi over 6, so this is the denominator I want. So 12 pi over 6 is 2, so if I want this scenario set up, then I would say the sine of 13 pi over 6 equals the sine of, well, this is 12 pi over 6 is 2 pi. So I'll put that here. And I have one more 6, right? 12 pi over 6 plus 1 is 13 pi over 6. So that is 1 pi over 6 plus 2 pi. Does that make sense? So you would say the sine of pi over 6 plus 2 pi equals the sine of pi over 6. Okay, and what is the sine of pi over 6? Well, if you remember on the unit circle, that would be the 30-degree angle, and the sine is opposite, so that would equal 1/2. So the sine of 13 pi over 6 equals, and I kind of ran out of room here, so let me just swing this over a little bit. That's not really that neat. So this is the sine of pi over 6. And the sine of pi over 6 equals 1/2. Okay, now it says using one of your colored pencils, make the point on the graph at each of the following pairs of x values. Okay, so I just copied over the graph from the previous page, so I don't have to flip back and forth. I'll choose green for these. Using one of your colored pencils, I use green, mark the point on the graph at each of the following pairs of x values. Negative pi over 4, which is right here. Go down here. Oh, there it is. That is the negative square root of 2 over 2. And then do negative pi over 4 plus pi. Well, if I add pi to negative pi over 4, that would be 3 pi over 4. And that brings me up to here, which is the square root of 2 over 2. And then if I choose 2 pi is right here. And then 2 pi plus a pi is 3 pi. Then those are both 0. And then finally 5 pi over 2. Here's pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, 5 pi over 2 is right here. And the value of sine of 5 pi over 2 is 1. And then if I add pi to that, then that's 1, 2, 3, 4 over, and that's down here, and that is negative 1. So now it says, what can be said about the y values for each pair of x values marked on the graph? Okay, so for each pair of x values, the y values have the same magnitude, but opposite sign. So magnitude, what is magnitude? Magnitude is the distance, vertical distance from the x-axis. This has a magnitude of 1. This has a magnitude of 1 in the negative direction, for example. All right, Jay, will this relationship hold for any two x values that differ by pi? And of course it will. So yes, since rotating by an additional pi radians produces a point in the opposite quadrant. So if you're in the first, you'll end up in the third. If you're in the second, you'll end up in the fourth, and vice versa. Then you'd have the same values, just the opposite sign. Okay, part K, butter. Part K, based on these results, make a conjecture by filling in the blank below. Okay, so for any real number x, the sine of x plus pi will give us the negative of the sine of x. L says, test your conjecture by selecting another x value from the graph and demonstrate that the equation from part K holds for that value of x. So if I go back to my graph and I pick any value, all right, so how about how about this one right here? We haven't talked about this one yet. That is 9 pi over 4. This is 9 pi over 4, right? 8 pi over 4 is 2 pi. Another pi over 4 is right here. 9 pi over 4 is root 2 over 2. Okay. So if I come back here, I would say the sine of 9 pi over 4 equals the square root of 2 over 2. If I add pi to that, the sine of 9 pi over 4 plus pi would equal the sine of 13 pi over 4, which equals, and then I go back to my table here, 13 pi over 4. Well, this is 9 pi over 4, 10, 11, 12, 13 pi over 4 put us at negative root 2 over 2. So that's negative square root of 2 over 2. And therefore it did work. Root 2 over 2, go over a pi unit, and we're at negative root 2 over 2. Okay, part M. Is the following statement true or false? Use the conjecture from K to explain your answer. So the first thing we're going to do is look at this on the graph. Sine of 4 pi over 3. So I'm going to come back here. The sine of 4 pi over 3. Well, where is that? 4 pi over 3. The sine of 4 pi over 3. Now we're going into thirds. So this is pi over 4. 4 pi over 3. That would be 1 pi plus a third of a pi. So if this is going to be broken up into 3 equal pieces, it'd be about like that. Okay. This is pi. This is 5 pi over 4. Oops. Oops. Okay. So how are we going to tackle this? Okay, so this statement is true. We could say the sine of 4 pi over 3. We're using the conjecture from K, like they said. Sine of 4 pi over 3 is 3 pi over 3, which is 1 pi, plus another pi over 3. And therefore, that has to equal the negative of what we're adding to pi. So that is true. And I could check it with my calculator and go like so. Remember, now we're talking radians now, so we want to be in radians here. And then I take the sine of 4 pi divided by 3. And I get negative 0.8660. And then if I take the sine of pi over 3 and negate it, negative sine pi divide 3, I should get the same number. And that's true. Okay. So now N says, using one of your colored pencils, mark the point on the graph at each of the following pairs of x values. X equals negative 3/4 pi. So I'm going to bring that graph down again. Okay, so here we go. What color have we not used yet? How about orange? Let's use orange. Here's orange. Okay, using one of your colored pencils. I chose orange. Why did that not do that? Okie dokie. Orange. Mark the point on the graph at each of the following pairs of x values. Negative 3/4 pi. Negative 3/4 pi is right here, and it is right there. That is the negative square root 2 over 2. Okay, negative square root 2 over 2. 3 pi over 4 is right here, so that'd be right here, and that is square root 2 over 2 positive. X equals negative pi over 2 is right here. That value is negative 1. And x equals pi over 2 is up here, and that is 1. What can be said about the y values for these pair of x values marked on the graph? Okay, for each pair of x values, the y values have the same magnitude, but with the opposite sign, once again. P, will this relationship hold for any two x values of the same magnitude but opposite sign? And explain how you know. So the answer is yes. If a rotation by x radians produces a point A comma B on the unit circle, then rotating it by negative x radians will produce a point A comma negative B on the unit circle. Okay, page 4, part Q. Based on these results, make a conjecture by filling in the blank below. For any real number x, the sine of negative x equals the negative of the sine of x. Test your conjecture by selecting another x value from the graph and demonstrating that the equation from part Q holds for that value of x. Okay, so here's an example. The sine of negative 3 pi over 4 equals the negative root 2 over 2. So if I go back to my graph, negative 3 pi over 4 is right here. And it is negative root 2 over 2. That's what's right there. All right. And then it says, and sine of 3 pi over 4 equals root 2 over 2. So 3 pi over 4 is here. And sure enough, this is the square root of 2 over 2 at this, about that level, 0.7. Okay. So the sine of negative 3 pi over 4 equals the negative of this sign here, which is root 2 over 2. S. Is the sine function an odd function, even function, or neither? Use the identity from part Q to explain. Okay, so if you take the sine of, if you take a function and plug in a negative x value and you get the negative of the function, that is an odd function. All right, so I'm just going to highlight this answer. It is an odd function. And the other way to tell is if it is reflected across the origin. Okay, so this point here would reflect over to here. This point here would reflect across the origin down to here. This point here would reflect across the origin to there. Okay, that is an odd function. So here it is in work. The sine function is an odd function because the sine of negative x equals the negative sine of x, and because the graph is symmetric with respect to the origin. F. Describe the x-intercepts of the graph of the sine function. Describe the x-intercepts. Okay, so here is the graph again. So here is an x-intercept, 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 and so on, and so on, and so on. So if you take pi and any multiple of pi, pi times 1, pi times 2, pi times 3, pi times 4, pi times 5, pi times 0, pi times negative 1, then we come up with this. The graph of the sine function has x-intercepts at all x values such that x equals some number n times pi, where n is an integer. Okay, you. Hey, you. Describe the end behavior of the sine function. End behavior, does it ever end? So as x increases to infinity or as x decreases to negative infinity, the sine function cycles between the values of negative 1 and 1. It oscillates down and up, down and up, down and up, and it repeats over and over forever and ever and ever. There is no end if you just keep going around a circle infinitely. Okay, so this is page 5, exploratory challenge 2, but before we get to that, let's just recap what we just did. We just realized or came to the conclusion that for all x, the sine of x plus 2 pi equals the sine of x because it repeats every 2 pi. The sine of x plus pi equals the negative of sine x, and the sine of negative x equals negative sine x. Okay? All right, so now we're going to talk about cosine theta. And again, as I was saying, there's no degree symbol here, so this will be measured in radians. Okay, so graph g of x equals cos x on the interval from negative pi to 5 pi. So the first thing I'm going to do is break it into quarters. So this is negative 3/4, negative 1/2, and I'm just going to put the halves. Negative 1 pi over 2, pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2, and 9 pi over 2. Okay, so now that that is done, we're going to plot some values. So if I take negative pi, okay, and again, let's recap the unit circle. Okay, so here we go. Here is the unit circle again to make reference to. Hopefully you have learned this and you can identify that that's a 30, 60, 90 triangle right here. But we're not talking 30 degrees anymore. We're talking radians, which 30 degrees is pi over 6 in radians, and you get a cosine comma sine all the way around. All right, so negative pi would be going to the clockwise direction around until I get to pi. And I'm doing cosine now, and the cosine of negative pi is negative 1. So I'll plot that point. Negative pi is negative 1. Okay, and then we're going to do intervals of pi over 2 for starters. So if I go negative pi over 2, cosine is 0. Okay, negative pi over 2, cos is 0. Okay, so then when I plot that, negative pi over 2 is 0. Okay, and then we're going to do 0. And the cosine of 0 is 1. So that's right here. Okay, so I suppose I should include other values, but it says here, and let me move the circle for a second, include all intercepts, relative maximum points and relative minimum points. Okay, so I guess what we're doing is okay, because there is an intercept, there is a max, there's a min. So I guess we're doing okay with halves. So let's just keep going. So now I'm going to do positive pi over 2, and positive pi over 2 is right here, and it's 0, comma 1. So the cosine is 0. So I'm coming back down at pi over 2, we're back to 0. And I'm just going to go around the circle once and then duplicate. There's no need to keep repeating because each multiple of 2 pi is going to repeat because that's a unit circle. Rotation of more than 2 pi is going to land in the same location, like we learned in sine. So after pi over 2, we're going to go to pi. And pi is negative 1. Okay, so I have done a full cycle from negative 1 back to negative 1. And now if I connect these dots, it's going to go something like this. Okay, so there is the cosine curve from negative pi to pi. It's going to repeat now. So 3 pi over 2 is going to be 0. 2 pi is going to be 1. 5 pi over 2 is going to be 0. 3 pi is going to be negative 1. 7 pi over 2 is going to be 0. 4 pi is going to be 1. 9 pi over 2 is 0. And 5 pi is going to be negative 1. So I'll just draw this in. Okay, so here's the graph completed from negative pi to 5 pi. Alrighty. And x equals negative pi over 2. Now it says using one of your colored pencils, so I'll switch to blue. Mark the point on the graph at each of the following pairs of x values. X equals negative pi over 2, which is right here. Okay, well that is 0. And x equals negative pi over 2 plus 2 pi. Well, 2 pi plus a negative pi over 2 is 2 pi minus pi over 2 would be here. All right, that's 3 pi over 2, and that will be a value of 0 as well. Now I'm going to graph x equals pi. Pi is right here. I have to come down to this point here. Pi is negative 1. Add 2 pi to pi, I get to 3 pi, and we're at negative 1 again. 7 pi over 4. Okay, now they're going into quarters. So 8 pi over 4 is 2 pi. 7 pi over 4 is 1 square over, and we are up here. And that should be the square root of 2 over 2, but I'm going to make sure, get my calculator, and we're doing cosine. And the first thing I do is go to mode, make sure we're in radians now, we're not doing degrees anymore. And I am going to put the cosine of 7 pi divided by 4. And I get 0.7071, and the square root of 2 divided by 2 is 0.7071. So that is root 2 over 2. 7 pi over 4. I could have also gone up here, and this is pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5, 6, 7 pi over 4 is right here. Cosine's root 2 over 2. All right, just verification. And then finally, when I add 2 pi to that, what I'm going to do is get to 2 pi, which is 8 pi over 4 plus 7 pi over 4 is 15 pi over 4. So here is 8 pi over 4, 9, 10, 11, 12, 13, 14, 15 pi over 4 is right here. And that is also the square root of 2 over 2. Okay, part B says, what can be said about the y value for each pair of x values marked on the graph? And the answer to that is, for each pair of x values, the y values were the same. Part C, will the relationship hold for any two values that differ by 2 pi, and explain how you know? Okay, so here we go. Yes, since the sine function repeats every 2 pi units, not sine. Why are we at sine? It's cosine. Pause. Okay, sorry about that. The key was wrong. Good thing I read it. Yes, since the cosine function repeats every 2 pi units, then the relationship in part B will hold for any two x values that differ by 2 pi. So I brought in my measuring stick, if you will. This is a length of 2 pi, as you can see on the grid here. And no matter where I move it, if the left end is on the graph, the right end is at the graph, 1 period over. So if I moved it to here, both ends are on the graph. If I move it down here, the left end and the right end are on the graph. No matter where I move this, the distance stays the same, okay? D says, based on these results, make a conjecture by filling in the blank below. For any real number, cosine x, cosine x plus 2 pi is still going to be equal to the cosine of x. All right, page 6, part E says to test your conjecture by selecting another x value from the graph and demonstrate that the equation from part D holds for that value of x. So how about cosine 0? Cosine of 0 plus 2 pi equals 1. Well, let's check that. Does the cosine of 0 equal 1? And 0 plus 2 pi is 2 pi. So does the cosine of 2 pi also equal 1? So if I go back to my graph, the cosine of 0 is definitely 1. That is right here. And the cosine of 0 plus 2 pi is 2 pi. And the cosine of 2 pi is, again, 1. So that is true. F. How does the conjecture from part D support the claim that the cosine function is a periodic function? Okay, well, like the sine function, the cosine function repeats every 2 pi units because 2 pi radians is 1 full turn in the unit circle. Thus, if we rotate the initial ray through x plus 2 pi radians, the terminal ray is in the same position as if we had rotated by x radians. Now G says use the identity to evaluate cosine 9 pi over 4. Okay, so cosine of 9 pi over 4. Remember, we want to, the identity says, is right here, add 2 pi, it's going to equal the same thing. So I want to say that 9 pi over 4 is some multiple of 4. Well, 8 pi over 4 equals 2 pi. So there's my value, and I had to take 1 pi over 4 away to get this. So I would say the cosine of 9 pi over 4 equals the cosine of pi over 4 plus 2 pi. All right, this is equivalent to 2 pi, and 8 pi over 4 plus 1 pi over 4 is 9 pi over 4. So these two are equal right here, and they will equal. And then what is the cosine of 9 pi over 4? So if I go back to here, well, here's pi over 4, 2 pi over 4, 3, 4, 5, 6, 7, 8, 9 pi over 4. Cosine is root 2 over 2. So I put the square root of 2 over 2. Okay, so I brought in the graph from the prior page. I'll use green this time. Using one of your colored pencils, mark the points on the graph for each pair of x values. X equals negative pi over 4 is right here, and I go up, and that would be the point square root 2 over 2. Negative pi over 4 plus a pi value would be 3 pi over 4, and that would be down here. 3 pi over 4, we have to go down to negative square root 2 over 2. 2 pi is right here. Where is it? Where's the graph at 2 pi? It's at 1. At a pi is 3 pi. 2 pi plus 1 pi is 3 pi. We're down to negative 1. And x equals 5 pi over 2. 5 pi over 2 is right here. Okay. Oh, I didn't plot this dot. 5 pi over 2 is here. 5 pi over 2 plus a pi is 7 pi over 2. And they're both 0. Okay, so what can be said about the y values for each pair of x values marked on the graph? All right, for each pair of x values, the y values have the same magnitude but opposite sign, and obviously 0, there is no opposite of 0. 0 is 0, so that's the one exception to that answer. J, will this relationship hold for any two values that differ by a distance of pi? Okay, so yes, since rotating by an additional pi radians produces a point in the opposite quadrant. So if we were in 1, rotating pi will get us over to quadrant 3. And if we were in 2, rotating pi would get us into quadrant 4, and vice versa, of course. Okay, so since rotating by an additional pi radians produces a point in the opposite quadrant with the same reference angle, the sign of the two numbers will have the same magnitude and opposite sign. Part K, butter. Based on these results, make a conjecture by filling in the blank below. For any real number cosine x, okay, for any real number cosine x, for any real number x, the cosine of x plus pi equals, and since we're getting the opposite sign, it's going to be the negative of, the negative of cosine x. Okay. Okay, page, All right, now page 7. Test your conjecture by selecting another x value from the graph and demonstrating that the equation from part K holds for that value of x. So I'm going to not bring that in. All right. Okay, so how about this? Cosine 3 pi equals the cosine of 2 pi plus pi, which equals the negative cosine of 2 pi equals negative 1. Ugh. All right, cosine of 3 pi. Let's go back. I'll do this in purple. 3 pi. Cosine of 3 pi. I said purple. Cosine of 3 pi is negative 1. Cosine of 2 pi plus pi is equal to 3 pi. That's true. And by definition, that has to equal the negative of cosine of 2 pi. So if I look at the cosine of 2 pi and negate it, I should get negative 1. So is the cosine of 2 pi 1? That's what I'm checking. So the cosine of 2 pi, there it is. It's 1. So the negative of cosine 2 pi would be the negative of that 1. And so that is true. M, is the following statement true or false? Use the identity from part K to explain your answer. Okay, this statement is true. The cosine of 5 pi over 3 is 3 pi over 3 plus 2 pi over 3, and 3 pi over 3 is pi. So that's where this second parentheses came from. The cosine of 2 pi over 3 plus pi. So since we're adding a pi to it, then we're going to get negative cosine of 2 pi over 3. Okay, so part N says to use one of your colored pencils. Okay, so this is getting pretty monotonous, don't you think? Use one of your colored pencils, mark the point on the graph at each of the following pairs of x values. X equals negative 3 pi over 4. Negative pi over 4, 2 pi over 4, 3 pi over 4 is down here. That is the square root of, or the negative square root 2 over 2. Okay, and then we want to do x equals 3 pi over 4. pi over 4, 2 pi over 4, 3 pi over 4 is right here. And that is also negative square root 2 over 2. X equals negative pi. That's down here, negative 1. X equals pi, right here, negative 1. What can be said about the y values for each pair of x values marked on the graph? Okay, so for each pair of x values, the y values have the same magnitude and the same sign. P, will this relationship hold for any two values, x values of the same magnitude and the same sign? Explain how you know. Okay, so part P is yes. If rotation by x radians produces a point A comma B on the unit circle, then rotation by negative x radians will produce a point A comma negative B on the unit circle. Q says, based on the results, make a conjecture by filling in the blank below. And it says, for any real number cosine negative x, cosine of negative x, yeah, that's right. That is going to be equal to the cosine of x. Okay, cosine of negative pi equals the cosine of pi. Cosine of negative root 3 over 4 equal to cosine of root 3, or 3 pi over 4, 3 pi over 4. So there you have it. R, test your conjecture by selecting another x value from the graph and demonstrating that the identity is true for that value of x. Okay, so just pick any value. So what's cosine of negative 2 pi? Well, that would be off the grid here, but negative 2 pi should be 1 because it repeats. And then cosine of 2 pi, which is right here, is also 1. So there you have it. So you can get further away and a negative is going to be equivalent to its positive on the other side. All right, page 8, part S. Is the cosine function an odd function, even function, or neither? Use the identity from part N to explain. So if I go back to part N, okay, the identity from part N, isn't that Q? Anyway, here it is. The cosine function is an even function because the cosine of negative x equals the cosine of x, and because the graph is symmetric with respect to the y-axis. So if we can reflect across the y-axis, then it is even. T, describe the x-intercepts of the graph of the cosine function. Okay, so let me go back and look. X-intercepts, they occur at pi over 2, 3 pi over 2, 5 pi over 2. They're all a distance of pi on the halves. All right, so here's how we do this. The graph of the cosine function has x-intercepts at all x values such that x equals pi over 2 plus some n times pi, where n is an integer. All right, so you describe the end behavior of g of x equals cos x. Is there an end? Okay, so as x increases to pi, it's been a long lesson, hasn't it? As x increases to what is that symbol? Infinity. As x increases to infinity, or as x decreases to negative infinity, the cosine function cycles between the values of negative 1 and 1. Apologize for that, I'm getting a little numb. Exploratory challenge 3, graph both f of x, sine x, g of x equals cos x on the graph below, then use the graphs to answer the questions that follow. Okay, so since we've already done this, I'm just trying to save some time here. Here is the graph of, notice how it reflects across the y-axis, okay? Pi over 2, negative pi over 2. So this is the cosine of x. Okay, so here is the graph of the sine of x. All right, I just wanted to save some time there because we've done this already. So there it is. We graphed f of x equals sine x and g of x equals cos x. So the cosine is in red and the sine is in blue. And then part A says, list ways in which the graphs of the sine and cosine functions are alike. All right, both functions are periodic and have a period of 2 pi. Both functions have a domain of all real numbers and a range from -1 to 1. Both functions cycle between -1 and 1 as x increases to infinity or as x decreases to -infinity. And both have similar identities, such as sine of x plus 2 pi equals sine of x, and cosine of x plus 2 pi equals the cosine of x. So there's just some similarities. All right, page 9. Yes, I said it, 9. 9 pages. 9. B. List ways in which the graphs of the sine and cosine functions are different. Okay, well, we stated above that f of x equals the sine of x is an odd function, and g of x is equals cosine of x is an even function. So one's odd and one's even. Where the sine function is at a maximum or minimum point, the cosine function has an x-intercept and vice versa. So what they're saying here is, right here, the cosine's got a max, the sine's at a 0. Here, cosine's at 0, sine's at a max. Here, cosine's at 0, sine's at a min, -1. Okay, so one's at an extrema when the other one's at 0. C, what type of transformation would be required to make this graph of the sine function coincide with the graph of the cosine function? So if I go back, the sine is blue, and what would I need to do? I would need to shift it to the left a distance of pi over 2. Or I would need to shift it to the right a distance of pi plus a half is 1.5 pi. So either way you look at that, that is what we would need to do. It'd be a translation left by pi over 2 or right by 3 pi over 2. Okay, so a horizontal shift, depending what direction you go, different distance. Anyway, D. What is the smallest possible horizontal translation required to make the graph of f of x equals sine x coincide with the graph of g of x equals cosine of x? Okay, well, I've already answered that. So the shorter distance would be going to the left, pi over 2 units. E, what is the smallest possible horizontal translation required to make the graph of g of x cosine x coincide with the graph of f of x sine x? So now we're moving cosine x onto sine, wrong direction. So if I move cosine x, which is red, onto sine, I'd have to move it to the right. Okay, I would have to move it to the right pi over 2 units. Okay, so a horizontal shift of pi over 2 units to the right. Now F says to use your answers from parts D and E to fill in the blanks below. For any real number x, what equals the cosine of x minus 2 pi? Or I'm sorry, 2 pi, pi over 2. All right, so if I look at this, if I subtract pi over 2, I'm moving the sine of x. So sine of x equals a cosine of x minus a pi over 2. And for any real number of x, the cosine of x is going to equal the sine of x plus pi over 2. All right, we're finally done. Page 10. Page 10 brings us to the end of lesson 10 and the end of this topic in module 2. Review the lesson summary. And I'm being serious about this. Review this lesson summary. You need to know these identities. It just makes things much easier from this point forward. Now go do your problem set.